This is a Morini 350 engine that's come in for a strip down and inspection. It came to a clattering halt because of a broken pushrod, and if you look at the pushrod you can see a ring of wear here, and an even worse one on the one that actually broke. And I think this is a fatigue break, because this wear is caused by the pushrod hitting the tappet. And if we have a look down here at these tappets, where you can see the upper edge is broken off, and you can see that there's a lot of movement in the tappet, and there should be none, essentially. So it was the tappet rocking that caused the damage to the pushrod, and eventually, due to the bending load on the worst one, caused it to snap. And there's play in the connecting rod as well that feels excessive, but we'll get a measurement when that's all stripped down. We've got more engine components over here on the bench, and again we can just make some initial observations. So the tops of the valve stems, oops, a little bit too far, are exhibiting quite a lot of wear, and if I rotate round you can see that this one actually has a ridge in the middle, and that has also caused a corresponding groove in the rocker tip there. So these should be savable. There's a fair amount of play in the bearings, but I've seen worse. And we have the cylinder here, which has got some fairly serious wear in it, and it's quite interesting the way it's worn. So you can very distinctly see the wear ridge there, but if you look, it's a long way down the bore, and if I keep changing the angle you might pick up there are in fact 3 wear ridges. So up the top here you can still see some honing marks, but a lot of scuffing, and I have positioned it with the most worn side visible, but you can see there's this mark, and this mark, and these appear to correspond to the rings. So if I bring the piston over here, you will notice this piston is like new. It has almost no signs of running, and I believe this engine had only been run for a couple of thousand miles. This is an overbore piston, which takes the engine capacity to 366 cc, to within a cc or so. It's usually referred to as the 375 piston. So there's still evidence of machining marks on the side, but the thrust faces are quite matte. Oops. And there is also quite a lot of debris in the back of that ring, and my suspicion as to what's happened here is that the barrel simply wasn't cleaned out properly after honing and has been left essentially with abrasive in there, which has worn this barrel out in very short order. but obviously the engine was worn before this, and we'll have to strip it down and take measurements and see just what can be done, particularly if the tappet bores are worn, whether it's worth trying to re-sleeve those and save the crankcases. Right. I recently built this engine disassembly and assembly frame, and it's designed so that you can mount the cases and also split them whilst mounted. But before I can mount an engine in there, I do need to take off the clutch side case, and to do that I need to strip the clutch. Now this proved to be a little bit of a struggle. The sleeve nuts had been over tightened and were quite stubborn to remove, but we got there in the end. And I removed the clutch plates, I've got them on the bench. And initial signs, it looks pretty promising. It's got the conical plate as the outermost one. You can see that there's not a lot of wear on that. But the next plate, that's got a lot of wear on it. And as we go down the stack, these steel plates really heavily scored. I don't think I've ever seen a set this bad. The plates aren't all that worn, so I'm thinking that it maybe has had a set of friction plates, but not the steels. So you can feel the wear between the worn surface and the dogs, which don't receive any wear at all. So there's not a lot of thickness lost, but these plates, you know, I don't know how they got so scored. It's like they've been running metal to metal. And I noticed one of the plates, not sure which one it was now, this one. If you look just down here, you've got a bit of torn metal on the surface there that would have just, and has done, created a gouge in the friction plate. Back to the engine, and there were hints on the inside of the outer cover. Having removed the centre drum, there's what remains of the thrust bearing that sits between the drum and the basket, and it's just been worn all the way through. So not quite sure what's going on there. There didn't seem to be massive amounts of end float, and this is usually the result of too little end float, or it's just old. However, the clutch drum itself is not bad. It looks, some of this is just dirt. You can see the marks wipe off, and the actual wear probably looks worse on camera. Doesn't, you know, if I get one of my horrors down from off the shelf, you know, this is just completely chewed up. This is more witness marks, and I suspect this has been replaced at some time. But we shall see what other horrors we discover as we delve deeper into the engine. As you can see, I've now got the clutch side outer case off, and it all looks pretty reasonable inside. The oil down at the bottom here does look quite black and sludgy, but we'll give what's actually in the main case a closer look when we get that far. In order to be able to split the cases, there are two hollow dowels, one on the upper front engine mounting bolt and one on the lower rear. So I have a drift, and I haven't taken them completely out. I've just taken it to just beyond the split line of the case. You can see it sticking out the back a bit there. So now we can get the engine onto the stand, and I'll put a drip pan underneath it first. With the engine now in the stand, I've taken off the front head and barrel, and we can see that that rod has quite a lot of play in it. And if I rotate the crank, bring the tappet up into position, by no means as bad as the rear, but definitely excessive play in the tappet or cam follower, whatever technology you want to use. If we can rotate the crank to bring the other one up. So not as bad as the rear, but certainly well below serviceable limits. So we'll keep on looking. And of course this stand allows me to lay the engine over up to 90 degrees as it is now, and this is a little awkward. I need the other hand really. Let's see if we can do it this way. If you watch the cam belt, I mean, I can feel play in this main bearing, but I had it yeah, you can see the tension in the cam belt moving as the crank is floating around in the main bearing. Now early engines used a ball race in this side with a hardened steel sleeve pressed onto the crank, and it was there was a sliding fit to accommodate thermal expansion. Then they changed to a plain bearing with a large journal on the crank where the hardened steel sleeve would have been, and there's an insert that fits in where the original ball race would have been, and you can tell at a glance if an engine is the plain bearing because it has 1, 2, 3 screws which are used to draw in the bearing housing and to press it out if necessary for a new bearing to be fitted with it to it. If you get a set of cases that don't have these screws but do have the bosses for the screws, then they're from a 250 twin which kept the ball race arrangement.